Okay, can you see my screen with the Jamboard?
Yes.
Okay, thank you. So those of you who already solved, like I said, I will mark and I'll mark properly and show you where's the correct and wrong part. But okay, I'll just go through briefly here. Here's the Jamboard is the same Jamboard that we've been using. Those of you who already have the link, you can just check with the same Jamboard link. If you want the Jamboard link, you send me your email address, please, so that I can share with you the link directly. So anyway, let's just go through 8.04. This 8.04. 8.04. Okay, so number one, convert these currents into amperes. So I think some of you know. I think, yeah. Let me just check your answers again. I think some of you don't know. Yeah. So remember that when you see M is same as is milli. So if you know milli, you must remember that milli means 1,000. So let's say, for example, if it's 1 meter is 1,000 millimeters. So that means for question 1A, how to solve. Okay, you remember that if 1 millimeter is 1,000 millimeter, even with second, 1 is 1,000 milliseconds. So this M just means 1,000. This M, not this M, the M in front of the other things one. The M, this M is milli. Milli means 1,000. So at not 1,000, sorry. My bad. Milli means 10 power of negative 3 or 0.001. So that's why 1,000 of 0.001, something like that. So to make it simple, just remember that if it's 1 meter, it's 1,000 millimeter. So 1 second, 1,000 millisecond. So milli is a small one, because you look at one way to remember is you look at your ruler. The millimeter is very, very small. 1 meter is very, very big. So 1 meter is got 1,000 of these things. So 1 ampere is 1,000 milliampere. So using that conversion, then you can calculate from here, right? So if let's say you're like, oh, okay, 1 ampere is 1,000 milliampere, then we need to calculate how much is 500. You count, you will get 0.5 ampere. Okay. If it's B, the answer, then you can use the same method to count, you will get 2.5 ampere. Who doesn't understand this milliampere ampere conversion? Where's my chat? Zoom has put away my chat. Can follow or not? This X.
Oh.
Okay, so you base on this number.
I thought I have to circle it.
Oh, okay. No, yeah, okay. This one is, yeah. Sometimes this book I notice. Sometimes I choose a circle. Sometimes they don't know what is clear. This one is 1A, 1B, 2 different questions. Yeah. Okay. So then question 2, I think then you should be able to solve for solar. But I'll give the answer here anyway. 2A is 2,000 milliampere. 2B is 100 milliampere. Question 3. So this is your dry cell, light bulb A, ammeter, switch, light bulb B, ammeter again, and then close. Okay, so that's the circuit. I think most of you got this right. I'll check again later. Sorry, because when I want to go to 8.05. I'll return and return to all of you. I'll mark correctly and return to you clearly. Those of you who did. So on B, mark and label the conventional current. So when they say conventional current, actually they just mean the normal current, because remember current flow from positive to negative, right? Electron is negative to positive. So when you see conventional panjang cerita, right, actually just asking you for the current. So just remember it's positive go to negative. So the answer for 2B, the current, this is positive, so you can anywhere on the circuit You don't have to draw so many. I'm drawing like many arrows here, but you draw one time enough. As long as it's the correct direction, you can get marks already. Okay. And then C. Okay. This one they gave you here is 0.5 ampere. Okay. It's not related to 1 and 2. So if this is 0.5, current is the same throughout the whole circuit. The current doesn't change. I think this one I didn't mention in the last lesson, but this one, do you all know or not? When current flow, current is the same in the whole circuit. Start to end, it's always the same. It doesn't change. Did you all learn this before? Do you remember learning this? Have you maybe you learned forgot?
Now I learn.
Sorry?
Now I learn.
Now you learn. Okay. So maybe you can do the correction in your paper if you wrote it a different number. Because one thing, a lot of students, they get confused. They always tell me, I thought, teacher, that by right the current should change because the current go through the light bulb, then it become less and less. Actually, no. Current is not, it won't change because current, right, is, if we look back at what is current is the flow of charge. So it's like rate of flow, how much is flowing every 1 second, because the formula is what? Charge over time. How much charge flowing in 1 second. So let me see, it's like a flow, the moment it sent out a certain amount of charge, is every 1 second how much charge. So one thing to remember is in electricity, I always call it electron world. Now in electron world, there's no traffic jam. You cannot have a lot come out, then suddenly here become less. If let's say here more, here less, what happened? Means, like, imagine on the road, a lot of cars are flowing suddenly. Okay, here the cars slow down. Then it's traffic jam lor. Now that's real world lah. That's human being driving cars. So if you suddenly go fast to slow, it's traffic jam. But the electrons are very smart. They got no traffic jam one. They cannot a lot, then slow down. If suddenly slow down means got a lot of backlog, a lot of suddenly stuck here. Electron cannot get stuck. The moment it gets stuck, it cut off the current, no more current flow. So the electrons when they flow, it's always moving at, like, you just remember it's like they move is very steady speed, very steady speed. There's no traffic jam. If anything happen inside the circuit, suddenly it's forced to slow down now. They're all very smart one. The moment it's forced to slow down, everything slow down together. They don't get stuck. And let's say here, like, it slow down, here faster, suddenly faster also is cannot, because suddenly faster means got empty space. Suddenly too fast and then nothing here, also cannot. So if suddenly too fast, all will suddenly become fast together. So maybe I add this note. Okay, if it's a single circuit like this, right? Okay, current is the same. It's the same throughout the circuit. So this one is important because a lot of students get confused. It's very, very common. A lot of my students also, no matter how many times they learn, sometimes they still get confused. So that now I write, and then you can write down in your sticky note, and then you stick somewhere, so at least you remind yourself so that you don't get confused. Current is the same throughout the circuit. There is no traffic jam. Okay, there is no empty space in the roads in electron world. Okay. Later we will see if got series, parallel, then how the current change. That one we later see. For now, we just focus on the fact current is the same throughout the circuit. Even if got series, parallel, or other things we add also, actually this is still true. The current is still the same, just that there will be slight change in the number, but in the end it's still the same. How much it start, how much it finish must be the same. Let's say like it starts 0.5. Let's go back to the question. Sorry. Let's go back to the question. If we start with 0.5, guarantee finish must also be 0.5. Cannot be different. So now, if it's only one road, no matter what, start to finish, all is the same, 0.5. Okay? Yeah. So just take note lah. This one I know a lot of students always get confused because they don't believe me. The reason is not because I didn't tell them. I tell them many times, but they don't believe me. They don't believe me that the current is the same. I think because they still thinking about other things. Okay, so just remember that current is the charge flow. How much charge is flowing every second. So it's how much flow out, flow, all same, 0.5 ampere. Then D, which bulb will go out if the switch contacts are moved apart? So because it's one flow, if you move it apart, then obviously both will shut off lah. So the answer for D is both A and B. Answer, you can say the circuit is incomplete. Incomplete. Okay. Question 4. Question 4, let me start a new slide lah, because no space really. Question 4. What charge is delivered if current is 10 ampere and time 5 seconds? Okay, the formula is this. Let me write the formula first. So if you look at your book, we already know the formula is charge is current times time. So then just matter of counting, you just take the current times time, but the current must be in ampere. You must convert into ampere. So, and the time must be second lah. If can, whenever you write your answer, always write the unit. If you just give the number, sometimes IGCSE depends on the year. Some year they accept, some year they don't accept. So to be on the safe side, always write the unit with your answer. So like A, 10 ampere times 5, 50. The in between, sometimes you don't write the unit, is okay. But the final answer you must write 50C. Okay. B is 250 milliampere, right? So I'll just change. You must, if let's say you get confused, you write out first, this is the conversion. Then only you take 0.25 times 40 and 0.25 times 0.25 times 4, 110, 10 coulomb. Yeah. Okay. Can? All right, let's go to 8.05. So the question for 8.05 is what unit? I think who wrote it wrongly? Okay, one of you wrote it wrongly. I don't call him unit. So it's not asking you for the full name. Unit. How's the measurement? All right. So 1A potential difference is volts. Okay. B is volt also. Let me just double check. Did I mark wrongly? Anyone? Okay. Yeah. I need to do correction here also. Yeah. Okay. So some of you wrote this. Some of you wrote voltage. Voltage is wrong, by the way. Voltage is wrong. Yeah, I think I better. Yeah, better take note. If you wrote voltage, I did write correct because I was looking almost all correct, but some is not correct. Let me see. Yeah. I will mark and I will send again. Okay, why is not voltage? Because voltage is not the unit. Voltage is the name of the physical quantity, like current. So for example, right, current is measured, the unit is ampere. This is the physical quantity. Quantity is what you can measure. This is the unit. Okay, example length. If length you measure in meter. So voltage is the quantity, the unit is volt. Okay, so not voltage. You don't say 10 voltage, you say 10 volts. Okay, so take note, please. I know it looks the same. But it end up actually is a different word, different meaning. So just be careful about that. Okay. Then C is coulomb because it's charge. D, I already gave you the answer, right? It's ampere. And energy, all of you already know. So whoever who got this wrong, you know yourself you got wrong. I think because you didn't understand the word unit. Okay, so unit means this one, all this measurement value. Okay. Question 2. 2A. I think some of you didn't understand the question as well. What type of meter is meter X? So what it means by what they mean here, what type of meter? Because in physics, the word meter means it's a measuring device to measure. You can measure something. Like you use a weighing scale. A weighing scale is also a meter actually. It's like a digital meter to weigh something, to balance something. So like you see, like what a weird name, meter and not the length unit, man. Actually, it's something related lah. But in physics, sometimes the word is very confusing. But yes, the word meter doesn't only mean the unit. The word meter also means a measuring device. Like here you got what kind of meter? Ammeter. So will meter come from there? Ammeter actually means ampere meter. Voltmeter, measuring voltmeter. Measuring volt punya meter. That's what they are looking for. Okay, so that's what they mean when they say, oh, what type of meter is meter X? What type of meter is meter Y? That's what they mean. Okay, so what do you think? X is what? Which meter? Ammeter or voltmeter? What do you think? Have you? I did learn. I did teach, but maybe I went through very fast because I thought you learned before. So X is which one? Ammeter or voltmeter? Oh, did someone say something?
Ammeter.
Ammeter. Okay, can see that X is 2A, right? Yeah, this is ammeter. Ammeter is always in series. That means when you connect, right, the ammeter is part of the circuit like that on one point. That's an ammeter. So ammeter is always like in the circuit, inside the circuit itself. So we say that the connection is in series. If you don't remember what series and parallel, never mind. We will cover in, well, not next lesson lah. I think the lesson after next. You have to learn about resistance first. Maybe it's not even the lesson after next. Lesson after next, maybe next week. Okay, so you because right, current is again what you maybe I do it this way. Because current, if you have a circuit, this is your battery, okay? Current, remember, is basically charge flow. So I got this circle here. Let's imagine this circle is the charge that's flowing. So current is because it's charge flow. This is arrow, in case you're wondering what is this. Charge flow. So what happens is whatever, let's say you got a light bulb, you know. Okay, so current is charge flow. So if this thing is the charge, I draw arrow because it's not equals. Now it looks like a little thing, pointing thing. Okay lah, I put equal sign lah. Okay, equal sign lah. Equal lah. Yeah. So anyway, so current is the charge flow. So that means the charge starts from where? You think of it like this for electricity. Think of it like this. The battery, this is positive. This negative. Current flow from positive to negative. So when the charge is flowing, it starts from positive, go through the circuit, go through the light bulb, and then come out. So current is actually charge flow every second. That's the formula. That means what? Every second, how much charge is flowing? If every second got more charge, means more current, no? If every second got less charge, less current, no? So the more charge is flowing every 1 second, the more the current. That's why when we talk about electrocution, electric shock, and all that, it's actually because of current. A lot of people thought, oh, high voltage can cause electric shock. Actually, it's not. It's not about high voltage. It's high current. The one that can kill people, one right, is actually because of current. Like you see people the defibrillator, the heart attack patient or something. That one is actually what? It's actually not voltage. It's current. When they do that, it's causing the current to flow through the heart to start back the heart. Current is the charge, is what's trying to get the thing to get the heart to restart. Voltage and current related. High voltage, sometimes high current. But the main thing you must remember is that actually it's not voltage that makes the thing start again. It's the current. So sometimes too much current can stop the heart. When the heart stops, then you put a little bit current in order to get the heart to flow again. So you remember it's because of the charge. The electron is flowing, carrying the charge. So it's a charge flow. Because we are measuring how much is the charge flow, so then now when we want to measure how much, we use the meter, right? The meter, you must put inside the circuit like that. So this will be an ammeter. So the ammeter is considered in series because when we measure the current, the charge is flowing, then go through, then the ammeter, okay, calculate how much is flowing through. So it's how much is flowing through. That's why it's on-site plug inside the circuit. But voltage or potential difference, on the other hand, is measuring what? Is measuring work done between 2 points. Okay, and if you look at the formula, it's divided by the charge now. But let's focus on the top part. That means every charge, let's say got a lot of charge, okay, got 500 charge, but each charge is doing how much work? It's a ratio, no? That's why they count. It's very fair when they always count based on every, like, let's say got 5 of you, how are you doing work? Then now we count, is like average. Out of so much work you all did, average each person did how much work. That's how we're counting in physics. So it's the work done between 2 points. Means now the charge, imagine this is, let's say this is 1 coulomb charge. How much work is going between here to here? So that means you must have the starting point. Okay, because where to measure work from where to where? Is it from start to finish curve, from this point to another point to a halfway point curve? So that's why we put two what's called 2 points here, because we need to find out, okay, the work start from here, we count. Then work finish here, we stop counting. So it's between 2 points. That's why voltmeter, to measure voltage, is always parallel. You will see the voltmeter got 2 points on. Like ammeter, ain't no point. No point. 1 point is inside the circuit. Voltmeter always got 2 points. This one we consider this to be in parallel. This one we say is in series. Okay. The connection I mean for the ammeter. Because for the voltmeter, you need to have the start and stop point. We start here, measure the work, stop here. If we put the voltmeter only on 1 point, here will be 0. Because why? How much work done between 2 points? Only 1 point, how to measure 1 point? So when you measure the voltage here, you cannot, because it start, no start, no stop. So end up 0 because consider like they didn't do work. So this is wrong. Let me change color. So this is wrong, okay? Same thing if you try to put ammeter like this, put in this position. When you put like that, it's wrong. Why? Because the ammeter now, remember the ammeter is measuring the current going through it. So if this is the charge going through it, it's measuring how much charge go through. The ammeter you put there, but the current is flowing here. Then the ammeter like, nothing come here, 0 Like imagine you are sitting here, you're waiting. Like let's say this is a track people are running. People are running, going here. But then the penjaga go and sit beside. Then this road, nobody, 0 nobody is running there. So it's the wrong path, wrong place to put. like the people running, you penjaga must sit here, check, oh, who is running, correct or not? They run correct or not? So that's why ammeter always we put in series, okay? So the ammeter for this one must place like this in series. In series means like in the same row lah, in the same row, okay? Same row, okay? This one is wrong, it's wrong, okay? This is wrong. It's the word wrong. Okay, so this one we use voltmeter, voltmeter. We use the voltmeter to measure. Okay, this one voltmeter must be in parallel. Wait lah, let me rewrite this nicely. So this one we use the voltmeter. We put in parallel. Okay, so yeah, so this is just for you to be aware. Okay, so that's why this one is ammeter law, and that's why B will be voltmeter. Can? Okay. Can I? Cannot. Am I talking to myself? Am I on mute?
Okay.
No, I'm not. Okay, thank you. Okay, clear or not? Ammeter, voltmeter. If you get confused, you must write down somewhere so that you remind yourself. Like you draw a simple circuit so that you know, oh, ammeter is like this, voltmeter is like this. See, what is the reading on meter Y? Because now we know this is a voltmeter. So remember, the voltmeter is measuring the work done. Here is 12 volts. Here's 12 volts. So you always remember, you look at the 2 points. This 12 volts is from this point, go through, not here to here. It's not here. It's not, oh, between these 2 points. It's not, it's not, The 2 points is, you must see, oh, here's the dry cell positive, Start here, go through, include this one, all the way until the end. Here. It's not, the dry cell doesn't count. Why? Because the dry cell is the one giving the power, is giving the electricity. So you cannot count across the dry cell, you count inside the circuit. So here include 4 volt plus B. That means what? This one is 12 minus 4. That's why you get 8 volts. Okay, because this 12 volt is from here, include the A, include the B, and I come back. That's why, oh, this is 4 volts, is 12 volt, 12 minus 4, this one become 8 lor. And then D, how much potential energy does each coulomb have as it leaves the battery? So this one we use the formula, which your book didn't write properly. The formula is, I think it's written there, but it's not, they didn't write down clearly. But I think I gave you the formula. Anyway, so the formula basically is PD is work done per charge. If you don't write it as work, then you write it as energy per charge. That means, because now it's asking energy is PD times charge. Okay, charge. So to count this, 9:48 already. Sorry, so many things to do. How much potential energy does each coulomb have? Coulomb is what? Coulomb is the charge. So that means each coulomb means 1 coulomb. So this one you take it as 1. So you want to count the energy. You see, oh, how much is it as it leaves the battery? 12 volt ma. So that means the energy it has is 12 volt times 1. So that's why you get 12. Energy is what? Joules. Okay. So this one energy is joules. PD is volts. Coulomb is charge. Okay. E, how much potential energy is lost by each coulomb passing through the bulb? So you see, passing through this bulb, this part, here, okay, this bulb is how much? 4 volts. It's lost. That means it's the work done, no? That means it's carrying 12 joule, carrying. Then you go finish, it will lose some energy. That's what they mean. So how much is lost inside? It means it start with 12. Here got how much? How much in between here is lost? It's 4 volts, no? Because the 4 volts is how much work done between these 2 points, ma. But that's the PD. So to count the energy, you just take the 4 volts, and they ask you for each coulomb, ma. So it's 4 joules. Okay. And then F asks us how much energy pass through A every second. How much charge pass through every second. So it's, you take back the formula of current, which is, no, sorry, your one is the other way. They write the other way. They write as charge equals current times time. So if you don't know how to solve this, then you see lah. Okay, you take the formula that you have. Charge passes through A. So then they give you A got second. Why got second? Then you find the one with time. Every 1 second. Okay, so then you count. Okay, the charge, I need to take the current. Current is how much? Remember, we start, finish, all must be same current. 2 ampere, ma. So 2 ampere times 1 second. So it's 2 coulomb. How much energy is radiated every second? The Zoom is blocking my view. So then how much energy is radiated every second, right? You take this formula back. Energy is PD times charge. Why? Because every second is 2 coulomb. So now you know all the charge is actually 2. Then the potential difference is 4. That's how you get 8 joules. Can follow? Let me mark the line in case you get very confused. Why so many things? This is the formula. Okay, this is the answer. If no questions, then that's it for this morning lah. Next lesson we will continue with resistance 8.06.